Test, test. Trouble in the room? Don Taggart? Feedback? Testing. Good morning. Hello, Sam. Me and you, eye to eye. You're going to be my anchor. Heart. All right, who's ready to jam? Oh, yeah. That's right. The jam stack. What is a jam stack? Is it a stack of jam? Or a stack of PB and jam? All above. My 5-year-old would be disappointed. It's not exactly that. So it was coined by Matthias Billman, CEO of Netlify, a modern web development architecture based on client-side JavaScript, reusable APIs, and pre-built markup. JavaScript, that's what the J stands for, dynamic actions in a request-response cycle done JavaScript, all done on the client. APIs, server-side process, database, blah, 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 reusable APIs. And then the markup, pre-built at deploy time, means you build a static HTML, CSS, JS website. Kind of a workflow of how this works. This is one example. There's various. You can have an editor that works with either Contentful is one of them. WordPress could be one of them. Shopify publishes their content to this serverless place, CMS. Developer builds the website through Gatsby that Robbie gave an example of. Uploads to GitHub. This all goes through to your CDN. So Netlify is the example here via webhooks. Initializes the build step, compiles all that, then deploys just static HTML out to the world. Stack site generators, Gatsby, Nux, Next.js. There's Gridsome out there. There's different flavors. Galore. Also, you can go to stackgen.com. It gives a nice variety of, there's like hundreds of these out there. The API layer can be Contentful, Shopify, Drupal, WordPress. There's lots. There's one out that just came out called Tina CMS. It looks pretty nice. It does kind of a layer where you can build within on the site, kind of similar to how WordPress does it, but it's all in React. Deploy your site. Some popular ones: Netlify, AWS Amplify, GitHub Pages, Now or Zeit Now does it. GitLabs. These are all some advantages from at least Jamstack's website: better performance, higher security. And they say higher security in that there's less vulnerability. It's mostly, your API calls are mostly made at build time. They can be within the static site itself, but there's less surface area there. Cheaper, easier. You can deploy on the CDN, and that's it. There's no server that runs this. Better developer experience. That's debatable. Disadvantages: making things simpler means you have more smaller pieces to orchestrate. So kind of how this goes is you have lots and lots of APIs, not just kind of one single server to run it all. So as you start adding more and more services, you kind of have more pieces you need to orchestrate. Build deploy time can be slow, so if you were to use this on a typical WordPress site that could have like thousands or tens of thousands blog posts, you're building all those each time you upload. At least on the Gatsby side, I know they're working on a way to do incremental builds where it's not building the whole site all at once, but right now that is a disadvantage. Now I hope I stack up to Robbie on this one. So my example is using Shopify. We're going to create a collection. I've heard here recently that some people like pizza. You like pizza? Great. You are one of the key people we are looking for. We're going to make a collection. Pizza. Save. Products. We're going to add a product. We can call this pizza tripping. Beautiful handmade pizza tray. Whole family. I got an image. Can I bring that over? Oh, it worked. We're gonna say this is 25. There's 5 of these. They're like 2 pounds, not 23. And we're gonna save. Now we're using Netlify. If I refresh this, when I just made that product, initialized the webhook that kicked off the build process on Netlify. Once Netlify is done, we'll see on this site you currently do not see pizza. Hopefully this goes quick. We got some time. So as this is kind of all going through this process, let's see here. Come on, finish. Okay, well while we're waiting for that, this is using Gatsby. So what we did is in the plugin section, added the source code, well, not the source code, the plugin for Shopify. Uses just an access token to the API, kind of within here. So that's using the GraphQL, and then throughout here we'll be able to access this API to pull down that data, similar to what Robbie showed. And then also reach out to that once this is built. Oh man, should have did this ahead of time. Published. Alright, refresh the page. Oh, now we have pizza showing up. Pizza plate down there. If we go to the... Oh no, it didn't build on that one. Oh. Come on. Okay. I was going to show off the add to cart and how it syncs back to Shopify and how you can purchase just all through the API. You have to take my word for it. And that's the gist of it. Any questions? Courtesy claps, I only heard one.
the ThoughtWorks radar up somewhere. Not there. Oh well. So this is a this has adopt label. So it is actually the second. I would say that, like, if you look at the circle on the radar, it's the second closest to the middle, which means it's the strongest adopt other than ESLint, which is funny, because ESLint's basically a given in front-end world. So, supposedly the founder of this idea is Cam Jackson, and he put out this article recently to explain more about this technique. And he's actually a consultant for ThoughtWorks. So imagine that. They want people to adopt their idea. So the gist of micro front ends is there's microservices on the back end where you break things up into small independent services, and it's a similar idea on the front end. The main objective is to allow multiple teams to contribute to the same user experience. And they say user experience rather than application or whatever, because each micro piece is technically its own application. Sorry, I got something in my throat, can't get it out. So basically, users should see a single seamless website, even though there are many separate applications that compose that website. And the main, I would say by far the biggest benefit of that is that it allows you to scale your front-end development rapidly. So if you've got a huge project, you can divide it up into a bunch of teams that can work on their piece of the project independently, and then those all get combined together to compose one thing as far as the user's concerned. And they're independently deployed and have their own independent pipelines and everything. So let's see. I should highlight it also allows teams to work with what they're familiar with. So maybe one team might use, I don't know, React. Another team might use Vue. Whatever. So or it could even be like, this team's on Angular 8, this team's on Angular 6. Like, you're not even, necessarily on the same versions if you are using the same technologies. So some of the pros: allows incremental upgrades. So if you're rewriting a monolith, that can be pretty daunting and a tough sell, but if you can sell it as slowly, piece by piece, replacing the monolith, then that would definitely be a benefit. As I said before, independent deployment. You should be able to deploy each with very little thought given to the current state of the other pieces, the other micro front ends. This document recommends that teams be formed around vertical slices of business functionality rather than technical or horizontal concerns, and some of those things, horizontal concerns like styling, forms, or validation. So you wouldn't have a validation team and a styling team and whatever. You should form around like the shopping cart team and the whatever, the catalog team and whatever. So let's see. Yes, went too far. So the most common approach is that each micro front end would encapsulate a single page of the application. Let's see. So so they recommend having like a top-level container application, and that top-level application renders common page elements like headers and footers, layout things, handles authentication and navigation, cross-cutting concerns, and brings various micro front ends together into a single experience. It basically tells each micro front end when to do its thing. Like, hey, you're up, the user wants to go to the shopping cart, now it's your turn, go. Let's see. So they have several different approaches that are talked about in this article. Build time integration is when each micro front end would be packaged into, for instance, its own NPM package, and then the container application would have those listed as dependencies in its package JSON. But it cautions against this approach because it kind of reintroduces coupling at the release stage, and so ideally you would integrate your micro front ends at runtime rather than at build time. It talks about, I don't have a lot of experience with microservices, but it talks about how there's a lot of pain seen caused by lockstep release processes in microservices, and you should avoid doing that in micro front ends for the same reason. Then it gives some runtime integration ideas, and it lists iframes as one, and even though it kind of generates like a yuck old technology response, it actually says it's not too bad. It seems to recommend that over the build time integration option, but it does make it a challenge for things like routing and browser history and deep linking and things like that. Oh, I was going to quickly link to the part of since people like to see code, this is the example it lists for the iframe integration. So you can see you've got one iframe here, and then you've got micro front ends by route, which is just like each route points to a specific micro front end, and then you load, as the route changes, you load that micro front end into the iframe. Right? So that's how that could work. Simple example. Then you've got using JavaScript to orchestrate which micro front end should be shown. So for that one, they show one script per micro front end, that's up here, and then each micro front end exposes a global function as its entry point, and so then this top level container would, based on the route, would call whatever that micro front end's like initialization function, its entry point function, and so that's how that one would work loosely. And then they also have the same thing with web components, and that's similar, but if you don't know what web components are, they basically allow you to define your own custom DOM elements. And so this is basically very similar to the JavaScript approach, but you're just using custom elements as your container, and then you're creating a DOM element of that type, of your custom element type, based on the route. So then it also talks about styling. So styling, you still want your developers to be able to write styles independently of each other and not have them conflict a bunch and stuff like that. So it talks about how there's lots of different approaches to get around that, just like there has been for a long time. You can use, BIM. You can use preprocessors like SAS with name spacing. You might agree to some specific name spacing ahead of time, or you can use CSS modules to apply styles programmatically, CSS in JavaScript libraries, and then even like Shadow DOM to kind of encapsulate your CSS from conflicting with each other using a browser-provided approach. Let's see, so then they also have, they talked a little bit about shared reusable component library as an option. So they were saying that I'll just quote them, the best models that we've seen are ones where anyone can contribute to the shared component library, but there is a custodian, a person or team, who is responsible for ensuring the quality, consistency, and validity of those contributions. And they talked a little bit about the pitfalls of if, no one's in charge of it, but everyone can do whatever they want in there, versus if no one's allowed to touch it and, just a team is dedicated to that, and this was kind of the middle ground that they prefer. So then this was actually the first thing I thought of when I heard what micro front ends were. How do the different micro front ends talk to each other? So the first thing is they say, avoid this when possible. So I thought that was funny, but I think what they're trying to say is only do it when necessary. If it can be avoided, avoid it, because it'll make your life easier from an architecture standpoint anyways, and sometimes it's a smell if you're trying to talk to each other too much. You're kind of violating the whole principle of micro front ends. But there are ways, if it's you have a good reason to do it, to send messages and events and things like each other. They caution to avoid shared state, but there are lots of ways you can communicate without coupling micro front ends together. They recommend custom DOM events, or in React, I'm not super familiar with React, but the model of passing callbacks and data downwards from a container to micro front ends, or even using the browser's address bar to communicate. You can get pretty creative about, just paying attention to what's in the address bar and reacting accordingly. As far as backend communication, they recommend backend for front ends pattern and one per micro front end, but this quote I thought was pretty insightful. It says, if the micro front end has only one API that it talks to, and that API is fairly stable, there may not be much value in building a backend for front end at all. The guiding principle here is that the team building a particular micro front end shouldn't have to wait for other teams to build things for them. So if every new feature added to a micro front end also requires backend changes, that's a strong case for backend for front end owned by the same team. So I think the key there is that the guiding principle is that the team building a particular micro front end shouldn't have to wait for other teams to build the things that they need. You're trying to avoid that dependency. As far as authentication, that's handled by the container. They gave an example of the container having, the login page, and then, handling talk to the API, get a token back, and then the container would the main application would own that token and then inject it into each micro front end so that they can use that token every time they need to make API calls. And then at the end, they listed some cons to this whole approach. Payload size, if you're building, 10 different micro front ends and all of them use Angular, then you might have 10 copies of Angular. The dev environment is not very much like production, so if you're one of those teams working on a micro front end, you're in your little silo doing all your work on, you're probably hosting it locally if you're using Angular, UNG serve, you're working on your little micro front end, but that's not really that reflective of the production environment. So they recommended having a lot of testing where all the micro front ends are present, in your production-like environments. So basically you're just further away from the final environment than you would be in a monolith approach. And then there's more stuff to manage, more repositories, more tools, more build and deploy pipelines, more servers, more domains, lots of things. So that's all I got.
Okay, is this a little better? Okay. So the original plan for this was 5 minutes. The last test I had was 6 minutes and 30 some odd seconds. So I'm going to see if I can pull it back in from there. So today we're talking about Graal VM and what can Graal do for me? So on ThoughtWorks radar, this is very accurately poised at assess. It's a universal virtual machine that's meant for polyglot execution. They have, it's built over a type of language called truffle, which there are multiple implementations of Ruby, R, Java, Kotlin is another JVM language that can run within this VM. It's used by a series of various micro frameworks like Micronaut, Quarkus, Heldion. The point is to provide two unique capabilities in the JVM space, and I'm going to go over both of those today. First of all, and this is from an article that I'll link here, there's a series of source articles that I pulled for this. These are at best kind of a summary and pointer to these articles if you want to go further in depth on them. But one of the execution abilities, I said, with this was a better just-in-time compilation target. Graal ships as an alternate C2 compiler on the OpenJDK framework, which means as they purport it, as a large application is run over time, it does better hotspot compilation than some of the other compilers. That, again, is up to your own testing to validate. The other half of that, which we'll do a lot more on later, is the ahead-of-time compilation. The idea for this is you can compile down to a native binary that you can run at the moment on Linux only that has a very, very fast start time, can use or is actually better adapted for small amounts of memory and for high-speed execution. There's some caveats there that we'll get to for a little bit. They also suggest that it's good you can combine JavaScript, Java, Python, Ruby, and even R, because there are target implementations of all those within Graal JVM. And there were a lot of examples I went through that said you could do cross-language and cross-functional calls using the different languages, kind of embedding one in the other, which looks sort of interesting. You can even run native language on the JVM because Graal can accept as a target LLVM compiled binaries. So if you have a C program that compiles to that as a target, you can run it on it, which I thought was kind of interesting as opposed to a native interface. One of the examples, interestingly enough, had Graal VM and the tool set that's available for various languages. You could use them like the Chrome debugger or the Visual VM inspection tool for other languages. So you could, things that were compiled and then running on Graal, you could use those tools to actually step through execution and gain some additional insight as opposed to unique tooling per language, which sounded kind of interesting as well. There were a bunch of other things. The article I'll link to had 10 things you can do with Graal, and most of them consisted of embedding one language in another, calling another language from another. They also included the terrible idea of adding code to a database. Don't do it. You could also create your own language against the Truffle framework. So if you happen to be or know a grad student working on a unique language, this will give you something else to compile towards and gain some tooling on that. So ahead of time versus just-in-time compilation. One of the important things and one of the capabilities that is leveraged by a lot of the small platforms. Ahead of time reduces your memory use, allows for a much, much smaller distributed binary, and much quicker startup time. I think Quarkus had an example. The other one starting in milliseconds instead of tens of milliseconds, hundreds of milliseconds. There can be significant improvements in the cold start. However, this was in another article, once you start to get to, I believe it was around 100,000 requests or execution, your ahead-of-time compilation efficiency starts falling behind your just-in-time compilation efficiency. And if you do some really specific profiling and tuning of your ahead in time compilation, giving it hints about which paths are going to be the most often executed, you can cut that down to around 1 million executions before the just-in-time starts to edge it out over time. So if you have a particularly long-running process that's executing lots and lots of requests for a very, very long time, either there or a different just-in-time compiler might end up giving you better performance over time, which I thought was kind of interesting. Also, ahead of time has some limitations for what you can do within Java. A lot of the micro frameworks work around some of these limitations that aren't available, or at least require some additional build time work. So be very cognizant of your code and dependent libraries. If they require some of these things, you're sort of out of luck as far as doing micro framework. There is a lot of stuff here. That is specific to the, I'm trying to remember what that section is. I'll include the link to that, but that's specifically Java library that's doing the binary serialization. I guess that along with reflection works if you send it a lot of compile time hints saying, I'm going to need these classes at some point, so you have to include it. Yeah. So again, you have to work around some of these existing limitations. Memory, much more efficient with using memory because you're not containing all of your class information and its overhead, but there are some limitations. Most of the recommendations said in Java in general, keep your data structures local. Don't share them. Make sure the compiler can reason around who's using them and when, and that will help the efficiency. Latency. This I thought was interesting. So garbage collection pauses can be a significant source of latency, and there are a lot of solutions out there. Hotspot, G1, CMS, ZGC, Shenandoah, all of these are different algorithms for dealing with large heaps and how do you efficiently do garbage collection over time without large pauses. Ahead of time compilation for the native implementation only has a simple stop and copy garbage collector, full stop. The article recommended you should have a heap no more than 100 or 200 megabytes in order to maintain efficiency. So you have to be very small and very efficient in using your memory. However, if you're only starting in a few milliseconds and can horizontally scale your application for short-running tasks, maybe that's not an issue. So take a look at what your use is, heap size, memory use, and see if this is a good fit. Ahead-of-time compilation also takes time. This was a simple Micronaut application, no plugins installed, one get endpoint that returns static content. Total compilation, 182 seconds. I was very surprised about that. I thought, okay. At first, I couldn't get it to compile at all because my local Docker VM only had 2 gig of memory and would go out of memory trying to compile this application. So I thought, okay, I'll increase it to 4 gigs, leave it at 2 cores. That's how long it took. Well, if I give it 4 cores, it'll go faster, and it did. I'm down to 2 minutes to compile. So for very simple execution path, I was surprised at this. So you may, depending on the complexity of the application, I'm not sure how much of this scales linearly, but this was compilation on an internal VM to do that execution path. Yes, it is doing a best case static analysis of available traceable endpoints and then compiling for all of them, not knowing which ones are going to be hit. One of the articles said, depending on your use and how you're going to run, you can run the target native executable in a profile mode that'll give you more information about the execution paths that are set, and then you can start to give it hints at compilation time saying, spend more time working on these pathways for better performance, although I'm not sure about how that affects your compilation time. And finally, remember, crawl is made by Oracle. The available containers that you can use and were used by Micronaut and I'm sure other products include the Community Edition that you can use. This is a compilation. It can be used for both runtime or compilation. The example Docker file I was working from used their default container to do the compilation. That was where I got the runtime in container compilation from. No additional information based on the compiled jar. The actual execution is an entirely different container and can be a lot smaller, probably even smaller than that Alpine one that's available. But of course, there's always the option of money. So I took a look and said, well, if I wanted to get the Enterprise Edition, what does it cost? Well, apparently it's only $216 a year per processor core. Huh. And, the Java SE subscription is a mandatory prerequisite for Graal VM Enterprise. Well, how much can that cost? Oh, it's only another $300 a year per core. So how do you determine per core for a high-speed startup application that may be deployed as a function as a service? I'll leave that to the marketing and accounting department to figure out if you have to license every core that may be available on your cluster, or if you're deploying this in AWS and you want to use their enterprise license as the basis of your container, do you have to license for the possible cores available for AWS Lambda per project? I don't know. It's worth checking into. Support, and I think some tools. I will commend that to you to figure out what's available. So in summary, and I'm running a lot over because I had some other things I wanted to say. Graal VM, it depends. Make sure that you have your profiling in place for whatever application you're currently looking at. Evaluate its memory use. Evaluate its use with and without their C2 compilation. If you are targeting an application, you have the additional framework available for horizontally scaling, and you need fast startup time, and you can work within those heap limitations, it could actually be a really good target choice. Or if you are specifically looking for a common tool chain polyglot execution, it may be a good opportunity. So I'll make sure those links are out there. Thank you.
All right. This is on. You guys hear me? Can you hear me? What? I hit the button. No? No? I'm not aimed at my mouth. Okay. Oh, let me get my timer out. I'm heard from people last week that I went a little long. So I'm going to start a timer, and I just did. So let me see if I can scoot this over there. Okay. So things I'm going to talk about today really quickly. I said really quickly last week, and you saw how that turned out. So I'm going to talk about Azure DevOps, Azure pipelines, and a thing called Concierge. Concierge is something that Dan and I put together. Yeah, so let's get started. You remember I told a story last week about pizza at my house. Me always throwing away the pizza boxes. There's a theme song if you didn't hear it. It's themed to the Brady Bunch, blah, 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 whatever. It's taken 36 seconds to get to this point. I realized last week that it's never going to get used at my house. I'm going to be the only one using it. So what I need to do is, because that would be hosted internally or whatever with Gatsby and all that kind of stuff. So I got to figure out how to build and deploy it. And so my tool of choice is Azure DevOps. I think this is in the you should be using this yesterday category. I don't know what that actually is in the thing, but this is Azure DevOps is one of my favorite things. I wish they hadn't called it Azure DevOps because it can literally have nothing to do with Azure. So just because it's called Azure and it's from Microsoft doesn't mean you have to use it for any of that. I think it's a very poor name choice, but whatever. So Azure DevOps has, and you can read all this, but it has boards so you can keep track of your work items, user stories, things like that. It has Azure Pipelines, which is one of my favorite things, and just for Dan, I'm going to show off. I love it so much, I spent my hard-earned dollar to order some custom stickers. I have extras if you want one, or when you want one, I should say. You can build and ship anything. So if you've got code and you want to put it someplace, you can do it. I just found that you can deploy to Netlify. I'm probably going to make one for Zeit, because I love Zeit, and I think that'd be cool. I have personally built iOS and Android apps with it and shipped them to the appropriate stores. So you can import all of your Apple certificates, all 47 of them. You need to make an Apple app, an IPA, sorry, or iOS app. So I have experience with that, and it's lots of fun to see that stuff automatically ship. So that's my favorite area of this, but there are other areas, so I'll talk about those. Azure Repos is just like GitHub, like a Git repo where you can put your code. You can have branch policies, so you can trigger builds when there's a pull request opened. You can require a certain number of approvers. I think a lot of this is pretty standard, but it's all in one tool. So everything that you create in the boards can be linked to a Git repo. And I'll demo that really fast here in a few minutes. But Azure Test Plans is actually one of the areas I have the least experience with. I know Theo has been in there a bunch, so if you have any questions about that, I highly recommend you talk to him. I know you can write the test plans using, I forget what it is, some sort of configuration file or whatever, and have that stuff automatically kicked off. I know your test results from build processes can also show up in there. Azure Artifacts is pretty cool. It's like your own private NuGet feed. You can also have NPM packages go there, and I think literally anything you can bundle into a package for like Java apps or whatever, you can put in there too. And then they have a ton of extensions that you can add for different things. If there isn't one, you can write your own. I actually made one once. It was really pretty easy. Just use PowerShell. I think you can use other languages, but so those are available. And then in my research for this presentation, I stumbled across this website, AzureDevOpsLabs.com. If you have a thing that you're curious, can I build this thing and how do I do it? You can go to this website and they have a whole kind of sample document on it. One thing that's a little frustrating with that is it's like, it's basic stuff. So it's like I have an Azure function, or sorry, C# code or Python, whatever, that I want to turn into an Azure function. It's only one. So then you start really quickly getting into the conversation of, what if I have multiple ones? How do you store those? How do you trigger a build on if I only edited one, but I don't want to reship them all? So like, it's really a great place to get started. I don't mean to knock it, but I highly recommend you go there and check it out, or you can come talk to me and I'll work through any of this stuff with you. So what I will show you next is, this is my personal Azure DevOps account. It's free to use. You can have 5 people use it with you for free. And you get 1,800 build minutes a month or something like that. It used to be a whole lot stricter. So whatever, it's free and awesome. So I'm going to walk through kind of these tabs. These are the same tabs that we saw the icons for on my slide. So here's like the landing page for it. There is a built-in wiki. So I made a wiki page. It's just markdown. I made some notes. Be sure to add a new pizza. This is actually a link to a task that's assigned to me in the board section. So I could, and I'll get there in a second, but I could click on this, and it would take me right to the task assigned to me in the same tool. I don't have to leave Azure DevOps to do any of this stuff, which I think is pretty awesome. 5 minutes. All right. 5 minutes gone. I don't have 5 minutes left. Anyway, so that's the wiki. I love that. You can put all sorts of stuff in there. You can make new pages, link these items, drop images in. It's pretty sweet. For boards, this is where you can manage work items. So I set this up as an agile workflow process or whatever, so I can go here to new work item and click, I can add a new user story and a task. I actually did that. So I need to add more pizzas to the list. If I click on this user story, you can see as a parent, we need more pizzas so the kids don't get bored with the food we feed them. Over here on the bottom right are 2 child tasks. One is talk to Tara about more pizzas, and I did that, so I closed that task. Add more pizzas to the list is a task, and these are both assigned to me because you can see my face there. So I click on this task. It's task 87, add pizzas to the JSON list. So we'll come back to that in a second. This task is associated to this user story, and you can see as I bob back and forth between those 2 things. It's all, again, right in this tool. There are other tabs here, so these are the ones that are, looks like they're recently updated. You can pick that they're assigned to me, things I got mentioned in, so on and so forth. You can filter them out, write your own custom queries. It's a really powerful tool. You can do Kanban boards with it. So you can click here, see my 2 tasks, moves across the board, blah, 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 you Kanban stuff. You can define sprints and things like that. This is just a DIY page, so I'm not going to do all that. But there's a lot of cool stuff in here. I'm going to expand this. So I'll go here to the repo. Last week, I demoed the Gatsby app, and I had a static file on my computer that I was running the Gatsby build process against to generate all my pages. Well, since then, I wrote a Java API because I wanted to show Todd that you can make a Java API in Azure DevOps. This is just for Todd. And build and ship it to, and I did it to Azure because that's a tool I know, but you could build it and ship it anywhere you want. So I wrote this Java API that has a graph QL endpoint. Please don't criticize or critique my Java code. This is a combination of years of Android tinkering and Googling. Tabs? Tabs? I have no idea. Yeah. They are properly formatted perfectly because I wouldn't have it any other way. So here, the pizza repository, I hard-coded the 4 pizzas we've got. So I'm going to actually open a pull request here in a second to add a 5th pizza, and then I'll show you the build and release pipeline that would build this, ship it, and then the UI part is the JavaScript compiled stuff that will I can kick off another build. It'll call this GraphQL endpoint and regenerate the pages, and then we should be able to see the fancy pants new thing up there. Here's a list of the commits of stuff I've done. I've only got 1 branch. You can see here on this branch, there's this little ribbon thing. This branch has policies set on it. So if I go here and go to branch policies, you can see that I need to check for linked work items, which means I have to have an associated work item with any pull request I open. And then I've got a build pipeline here that will automatically run when I open a pull request. It's completely untested. I just did this morning, so we'll see what happens, but I've done it enough. Hopefully it'll work. I don't have any pull requests yet. Pipelines, like I said, is my favorite area. So I've got this UI pipeline and an API pipeline. The API, if I edit it, what it does is it reads my Maven POM XML, and it generates a package. The goal is a package. Then it copies the artifacts to a staging directory and publishes it. I have to publish the artifact so that the release pipeline can pick it up. I set here a trigger so that when the master branch is updated, I want it to automatically kick off. So we'll come back to that in a minute. And then there's this releases tab where clearly it was iterating, trying to make the UI, update the UI to call an API and not the static file. So if I go here to API, I can edit this. And you see there's the API. This little lightning bolt with a check means it's continuously deploying. So whenever I get an API, you can filter it by branch. So I just did master for now. And the pre-deployment condition is whenever the API is built from the master branch, I want to kick off a build to production. You can have Git flow where you have a develop branch that goes to QA. You can trigger all that kind of stuff. And literally this just deploys the WAR file, WAR whatever file, to an Azure web app in Azure, which I think is nuts that I had no idea what I was doing and it just worked. One of my favorite things here you can do is set up a library where you can have variables that are pulled in.
Is there a way to link your release to the commits that were included?
Yes. I will show you all of that in just a second. And it's all in one tool. Libraries, you can create these variables. There is so much stuff here, and I'm already at 11 minutes, so this is nuts. Like, there's so much awesome stuff I could show you. You don't have to have any variables in source control. You can pull it from here. You can create an Azure key vault, put all of your keys there, and then during the build and release pipeline, pull them in and replace all those variables in your outputted config files, app settings.json for .NET. I've done it for, or I'll show you how I do it for the Gatsby app. It's crazy. And then here's the test plans and artifacts. I'm going to skip those because I'm running out of time. So I will find my API. It's not on the right screen, shocker. Not that, sorry. Where's my note? So right here, add a new pizza. It's the new pizza row. What? That's the cook time. I know it's clear as mud. So here you can see I did get diff right here in, am I on the master branch? Add pizzas, get add. Every time. It's a Windows command prompt is dumb. So git push, I don't have that branch committed or added yet in Azure DevOps, so I'm just gonna copy that command and push it. Then if I come back over here to Azure DevOps and go to repos, files, wow, that's weird. Anywho, it would have shown up in here and I could have opened a new pull request, so I guess I can't demo that, and that's fine because I'm running out of time. So anyways, I could have opened a new pull request. Let me see if I can, just on the fly. I'll pull up a Kappa app we've been working on internally. So if I go here to work items, here's something, create an initial Angular app. Here's the user story. Over here on the right, you can see related work. So you can see like pull requests and tasks that were updated. You can view, there's a whole lot of stuff in here, but these are the tasks. And then I think this is a pull request. So if I click on that, it takes me, nope. Oh, sorry, they're up here in the development thing. Here's a pull request. So I click on that. It opens up the pull request. You can see what files were changed for this pull request. A whole bunch of files were added. Over here, you can see that the build succeeded. So I had set up a pull request build, so that had to succeed. And then we had to associate a work item for that thing to get closed. So that is, in a nutshell, one of my favorite pieces of software I've ever used, Azure DevOps. There's a million things more I could say. But you might be asking yourself, oh my gosh, this is crazy. This is overwhelming. I don't know how to get started. So the thing Dan and I made is called Concierge. What you can do is with one command, it will, in your own Azure DevOps project, or sorry, organization, it will create a project. It'll import sample code. It'll set up a build pipeline file. And basically, all you do is create 3 variables and hit the go button. So I'm going to demo that now and say a quick prayer before I do this, that I got everything cleaned up ahead of time. So this is in Python, the Azure itself has a CLI written in Python. Then they have an add-in for Azure DevOps that you can create projects and do all sorts of stuff with. So this is another AZ. If I run AZ, it's the Azure command line. It's all open source, and so that's how I did all this is I just researched it and learned what you can do. Blah, 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 blah. Right here, you'll see the concierge row, create a new Azure DevOps project and associated Azure resources. So I'm going to run this, and I realized you can't see that at the bottom, but it's Azure concierge create. I'm going to specify an organization, the name of the project I want to create, the location where I want my resources in Azure, the resource group name, which is kind of like a bucket you can put stuff in Azure. The site type is a web app, and the site name is rptest1. I'm just going to name a bunch of stuff that really fast. So I'm going to hit enter and see what happens. So it says it's ready to create resources. It's creating the Azure DevOps project. I think I left the Azure resources there in Azure because it's kind of slow to do, but so it might fail here in a second, and that's okay. Importing a sample repository. Sorry, I'm almost 2 minutes over. It's creating the Azure resource group, creating the Azure resources in the resource group rptest1. Apparently I didn't clean those up, that's fine. So if I go here to the E-G internal, I can scroll down here and here's RP Gatsby test 1. I can go here to repos. There's a whole slew of Gatsby code that calls the API that I've already set up, the Java API. If I go here to pipelines, there isn't one yet, but check this out. I can create one. I can say my code, so it's a YAML file, my build and release definition is in an Azure repo. It's in here. It found that file because it's at the root of the project, and it says trigger on master, run it on Ubuntu, build it, using npm build, blah, 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 and publish the artifact. And then the second stage is to deploy it. So you'll see down here, there's this $ parenthesis Azure subscription, $ app name. And then I know, and it's all in this content right here, I know that I have to specify the API URL that I need Gatsby to call to generate all my pages. So we're going to go ahead and define those variables really fast by clicking variable over here on the side. So API URL, and this gets replaced in the code during the build process. And actually, sorry, this one doesn't. This one is environment variable. So you can set environment variables up that can get read. So if you have like process.env, this will read them. So I'm going to click OK. I'm going to add another one. And then in a second, I'll go back and check on. So these are, rptest1 is what I pulled in the Azure concierge command. Azure subscription, I'll show you how I did that. Please tell me I spelled that right. Let's say Azure subscription, I can't see it from here. YOLO. So we'll save that. I'm going to click the save button. I don't want to run it just yet. So it creates a pipeline. And then I need to come down here to project settings, add a service connection to Azure. And this is all in that comment at the top of the YAML file. rptest1. And check this out. I go here to resource group. What resource group? rptest1. That's what concierge created for me. All I did was enter that one command. So I'm going to allow all pipelines to use this connection. Swap back over here. Boom, all my resources are created, and that is awesome. So if I come here to the Azure portal, oh, it's setting it up. It's like, what is taking so long? I've got an application name here, rptest1, but I'm going to go here and show you instead the resource groups. So rptest1, and then there's an app, and an app service plan rather, and an app running in there. This app service is what was generated using a ARM template. So I said I want a certain plan size and certain location or central US. I want it to have, you can set it to have SSL enabled and put in a certificate. You can have domain stuff. You can have it set to always on, turn off Java and PHP, so on and so forth in an ARM template, but that's a completely other different topic. So anyways, this resource is sitting here ready for us. My service connection is ready. So if I come back here to my pipeline, I'm going to edit this. Actually, I don't need to edit it. I already saved it. I'm going to click Run. You can see here there's two stages, build and deploy. The build stage is using that YAML file that got imported from a sample repo I have. So it's going to build and deploy it. We don't have to actually sit here and wait for this. It works. You can just trust me on that. I'm going to stop talking here in a second. One thing that I wanted to point out about Concierge is that it right now only does, you can pick between an Azure function, so it would do the same thing, create a project, pull in a sample function. You can create those same 3 variables and deploy it to an Azure function, and the ARM template defines an Azure function with a storage account and all that stuff. Or you can do this particular Gatsby app. This Concierge project, I keep pointing at the screen, that's not where it is. This Concierge project is on our EG GitHub page. So one thing I'm kind of hoping is that if people come to me with a, hey, I've got this project, I'd love to be able to demo really quickly how you have a JavaScript front end that uses OAuth tokens from Azure Active Directory. This sounds like a thing I've had conversations with people with lately. How do we do that? We could set up a sample and then edit Concierge to pull that in and run it and import it and set it up. And so it's like this great, really fast way to template a new website. So Azure DevOps and Azure Pipelines are the 2 things I want to talk about today. Would I recommend using them? Obviously. I mean, I made a sticker. And Concierge is, if you have any questions about that, I'd love to talk to you about it. I could show you the Python code I wrote, have a sample that you can import, an idea for that. I'd love to talk about all of it. Yes, sir. Yeah, so it's not a question anymore of how do we have an Angular front end talk and get JOT tokens to Azure Active Directory. It's a skip all that and just start. So I think that's a thank you. I think that's a great example. That's one of the ones where it was just like I've had conversations over the last few months or whatever where it's like this is what we're trying to do, and it's like I know we keep having to redo this. So I think for Sweet Spot. Thing I'm talking to Jacob about. We had to do it for a client. We might be doing it for this new client. So here's the build output. Yay, it works. This is the public side I can tell my wife about that she won't use. So, anywho, that's all I got. Anybody else have any other questions? Sir.
Is there any documentation on the concierge stuff where people could go look at?
Yeah. It is at. I need to push my latest changes to it, but yeah, there's an Azure CLI Concierge extension repo. This is in the EG thing. There's a README. It was inspired by this DevOps demo tool, so you can get help. Here's the command, basically, I just entered. Yeah, it's a little light on documentation, but I think that's kind of like a great, that and supporting more like doing 2 things at once. So like having an API and a front end, both. Like I want to specify the front end as Angular and the back end is Java, Go, or a Java API that uses Azure Active Directory, kind of the example Dan was talking about. And the Angular front end could also be. So it just that kind of thing. But yeah, this is out there, and I'm happy to talk about it as much or as little as you want to. Thanks.
Hello. Let's see. Is this connected? Okay, that worked fairly smoothly, surprisingly. So I didn't do a ton of preparation, so I don't have like a really intricate demo, but I'm going to talk about what I think about it and tell a story. And that's the plan. My first topic of the two that I'm going to talk about is testing using real device. It is a technique, and it is in the adopt. I can't understand why it wouldn't be in the adopt and why it's, I guess maybe it's new because of when it was there, but it just seems kind of obvious, so I'll go to the next slide. Because, in the past, we think of testing an environment that is set up as close as possible to production and avoid production bugs, but now that we have like embedded or IoT things, this is saying that we want to test on an actual device, and the whole like kicker is getting it into your CI/CD pipeline. So as soon as we had that kind of processes, I feel like, as well as embedded stuff on devices, it makes a lot of sense to kind of tie those two things together. I haven't ever done anything with it, so all of this was just like new research for me. So if anyone in the audience has actually done anything, please chime in and add some of the Robbie Page kind of enthusiasm to my presentation. I just decided I would tell a story because I feel like I have one in my life where my desk kind of looked like this, and there are reasons why this would have worked and why this wouldn't have worked on such a project. So in the beginning of my time with EG, I was working on Zed. So I see some Zed faces out there, and they had an application that was running on both Android and iOS, as well as another device that was doing the ODB C2 whatever, the port thing in your car thing. So these are all the actual things that we were doing. Sometimes we were testing with that device, sometimes we weren't, and we were testing on our mobile devices. So one of the advantages is obviously so that you don't have this whole thing on your desk, but then all the other testers don't have any of their devices and things like that. So you can run your tests like as your like remote, what is that called, on your device cloud and things like that, so that you don't have to like actually possess the devices. Problem with Zed is, in order to do everything in the real way, it needed to be with you in the car. So I do feel like maybe there was some creative solution for that, but in your car, if you're testing, or if you're in a truck out there, the phone needed to be present with the adapter that we were using. So that just presented a situation where, I was challenging myself to think through a real life situation where it may or may not have worked. But anyway, there are many benefits that I was reading about, basically with remote and virtual teams. Your tests can be run then on the actual device. You can like script it as an automated test in your CI/CD pipeline, and then actually run it on that phone or tablet or whatever else. I also thought, you know, acquisition of a specific device versus using a device in the cloud, because then suddenly you've bought this, maybe you have to buy like an iPhone 5, but then you don't have to support it next year. You know, you've invested a ton of money, maybe buying like a really old device, and then it's gone, and then you just like use it, and the clouds are managing that. So that's just like a typical advantage of using a device cloud, but the tying it into your pipeline is really helpful. And then I don't know what I meant on these bullets. I think I wrote them weird, so I'll rephrase them. But basically, I believe what I'm saying is just that there are more differences between the devices, and versions can change more when you have more devices right out there. So since we're not just writing software to be put on a server somewhere or on a web page or whatever, then we need to also emulate that. I started a list of resources because many of them were talking about different pipeline tools that in how to put them into your pipeline and how to do it. But reading through them, it was, you know, it just didn't get to the point where I felt like I knew the right one to choose to try to do a simple demo, since it's something that I don't do every day. So this is the end of what I was going to talk about with testing using a real device, but I am interested to hear if anybody else has actually done this with a client or has any other additional comments. Thoughts? Mm-hmm. That's true, yeah. Yeah. And I did remember one thing too. I had done some testing before with some of the device cloud stuff, and I think there was a little bit of like getting the same level of results documentation, because everybody's going to want something different. In this case, you might want a screenshot or something, or in another case, and I mean, maybe you just find out this test failed and then you can reproduce it manually to create what you need in some situations. But you know, at that point, it's really situational what you would need. So I think it kind of piggybacks on what you said. That reminded me I had that thought that I forgot to document. Anything else? Yes?
The device cloud providers, what do the cost structures look like? So is it, you pay by number of categories of devices, total number of devices?
You know, I don't know how the cost is. I know I did some testing on this like probably over a year ago with AWS. And I definitely stayed within the free tier, so I know there was a limitation on number of devices and number of versions and stuff like that. But that is a good question. I can look into that and maybe post it in my notes. I think that there were two, and I remember AWS Cloud, but I don't remember the other one that I was looking into. So yeah. And the other one, I am here to just coordinate conversation. I did a little tiny bit of research, and I'm sure everybody in this room probably knows a lot more about this type of thing than me. I don't even really know if ESLint stands for something. Oh, okay, thank you. I just realized that would have been a good thing to look up when I was doing my brief research. But it is a tool, and it is in the adopt. And when I read the description, it once again seemed like it made a whole lot of sense to be in the adopt. It sounds like it would help when writing JavaScript code, that it would help with standards and formats and things and rules. So, but really, I'm here to say, does anybody have experience with ESLint and stories and exciting things to share? You use it.
It's part of your, yeah, part of your build, right? You run it as a static analysis. Yeah, usually it integrates with different browsers.
Okay.
And like a lot of the front-end frameworks have predefined like ESLint or TSLint rules that are automatically there when you generate the project, and if you want to customize them, you can. You can add in new ones or pull in plugins and different things. And then when you
Mm-hmm.
It runs the linter, and if you do things right, it'll break build. So
Yeah.
everyone
Okay.
do things the same way.
So is it, are there predefined ones that follow sort of industry standards, or do you get to create your own rules, like standards for a project?
If you use a front-end framework, there will be a predefined one that you can then customize if you want to. If you don't use a front-end framework, you could like download a standard one and extend it based on
Okay.
that, or you can like start with that baseline and then add your own stuff.
Okay.
So Joel, with ESLint, so obviously JavaScript doesn't give you a lot of help, statically typed languages do. Is ESLint help with that? You said it was a TS. So TSLint is for TypeScript, and it's actually being assumed by ESLint very soon. So the TSLint is going to be like, hey, stop using this, use this. But
Mm-hmm.
back to your question, I don't exactly know. I've never used ESLint on TypeScript assembly yet. You're asking for JavaScript stuff. Does it tell you TypeScript? I don't know. I guess I don't think it necessarily does. Maybe if you have like Flow or things integrated in, I think those are generally more for that typing type stuff. Then, but so is it? So then is it more for like style? Yeah, I would say it's more for style. So can you configure it then? So like one example as in TSLint, which is what Angular still uses. I downloaded like this extension or whatever plugin.
Check, check. All right, so you guys ready to roll on to TensorFlow? This is, this will not be a deep dive. This will be just enough so you don't look like a fool at a nerd party. Yeah, I don't think so. Yeah, so you could have a conversation with like BizDev or something about this stuff if you pay attention. So what is TensorFlow? It is an open source library for numerical computation and large scale machine learning. It is very useful for deep learning modeling. So I will talk more about that as we go further. It is in the trial, and I think the only reason it's in the trial is because they just came out with 2.0, which was almost a complete rewrite. So there are some things that you'll have to change because it's not backwards compatible. It didn't sound like it was a big issue, but the main thing they added was eager execution, which we'll get to in a little bit. But one of their competitors uses that, and people liked having the option. But yeah, I mean, this is like if you're using deep learning, you're you're using TensorFlow, so I don't know why it wouldn't be in adopt. Eager execution instead of doing your full graph. Yeah. Okay, so this is just trivia. What is a tensor anyway? It's a generalized matrix, so it could be one-dimensional and up to n-dimensional. So it's just a generic term for any sort of matrix of any size. So you can see it could be a scalar, a vector, matrix. It could be huge. How does TensorFlow work? So it bundles together a slew of machine learning and deep learning models and algorithms and makes them useful by way of common metaphor. It uses Python to provide a convenient front-end API for building applications with the framework while executing these applications in high-performance C++. So, you know, you monkey around with the Python stuff, getting it to write, but that's not what it runs in. And as you see there, the big win with some of these TensorFlow and its competitors is they can get to the GPU, which claim to be up to 1,000 times more performant than the CPU. And then this TPU is like a TensorFlow performance unit, which, you know, Google's now, you know, building these, you know, these GPU boxes and systems out in the cloud that you can buy cycles on. So, so the GPU is the big win in TensorFlow. So the way that it gets there is by way of CUDA on top of NVIDIA. So if you have a Mac, it's not going to work out for you right now because NVIDIA and Mac they're not good with each other. Apparently there was some incident back in 2012 where NVIDIA's chips melted to the socket and they were soldered in and they didn't want to pay for it, so Apple got stuck with the bag on all the repairs, and they're no longer talking, I guess. So anyway, if you want, like, I don't think this is something you would just do normally on your MacBook Pro, like in real life production of like some super deep learning thing, but you would not be able to unless you like did a bunch of monkeying around. Okay, so the most widely used machine learning languages is Python and R. So we're going to go down the Python trail and just leave R. That's a different day, different topic. So these are all things that sit right on top of Python: NumPy, Pandas, SciPy, scikit-learn. There's natural language processing, the plotting library. So all these that's just kind of right on top of Python, and that's what you can mostly use for just your normal machine learning stuff. So enter TensorFlow and Keras. So TensorFlow is a low-level framework for deep learning. It's very fast, flexible for training since it can use the GPU. And then Keras would sit on top of that. Before 2.0, TensorFlow 2.0, you would just throw Keras on. It was its own thing. Now it's in TensorFlow. And Keras used to run on other backends. But next release, it will only run on TensorFlow. So it's just a high-level abstraction, and it's got like everything you would ever want to need for machine learning. So there are some terms there: artificial neural networks, deep learning. So I'll explain a little bit of the difference between deep learning and machine learning. So machine learning typically would be something like, we'll do the image recognition thing for the metaphor for this. There's linear regression and there's time series forecasting, but we're going to do classification, like image classification. So you would, for regular machine learning, it's something like this is a picture of a cat, this is a picture of a dog. They're all labeled, and you feed it in, thousands of images, and then since you've labeled it, it knows what it is, and then it tries to figure it out the next time you feed it in. With the artificial neural networks and deep learning, you just feed it in a bunch of images, and so it has to have a ton of data, and it's like, and it has no concept of fur or a tail or cat face or whatever, right? It's just like looking at all the images and like trying to build some intelligence by, looking at the images and doing some math. And so then when you throw a picture of a cat in there, it's like, oh, this has this, and it doesn't, it doesn't know words. Like, it's like, this has this stuff, which we would call fur. And so then it would try to classify it. But that takes a ton of layers and processing, so that's why they call it deep learning. Who are the other players in this space? PyTorch, which is Facebook, wrote that. AWS is the MXNet, and then Microsoft is the Cognitive Toolkit. TensorFlow is the leader. PyTorch is probably second, and yeah, I don't know about the others. Okay, this is, if you go to any introductory machine learning talk, this is one of the things you're going to see. Even the world's most advanced machine learning platforms are tripped up by our facetious Chihuahua versus Muffin challenge. A human toddler beats deep learning when it comes to figuring out what's food and what's Fido. So this is hilarious. I mean, it's super interesting problem space, because as programmers, we're like, okay, how would we make this thing recognize? And you're just like, oh, it's got to like see a gazillion images, and then it's got to, and then it's so fascinating how I'm like, I could show a 2-year-old, I could show him a Chihuahua for 3 seconds, then I could show him a muffin for 3 seconds. So that's all the training. Whereas if you were doing this for machine learning, you'd have to train it like a gazillion cycles of a gazillion images. And you could just show a kid, here's a dog and here's a muffin. And then they'll go, muffin, dog, they would know. So it's just kind of interesting. So I think that's funny. And there's a boatload of those out there. There's like pug versus loaf of bread, and labradoodle versus fried chicken. So it's really funny if you go looking for them. Okay, so how would I get started with this? This is where I'll just kick out to here. There are 3 different ways. One, you can install it. Just, oh, hey, let's end. Let me end my show here. Hey, come back. Where's my mouse? Okay, so you can install it, which is a lot of work. You got to download packages and run pip and all this stuff. Docker containers out there, which is another way to do it. And if you're super lazy and you're just goofing around, you can use Google Colab, which is it's basically like a Jupyter notebook out there that you can just run what you want. So here's the image classification. They've got all kinds of these little tutorials and examples, and I'm not going to get technical at all. I'm just going to kind of show you what some of them are. This is like an image classification one. So if I run it in Google Colab, I'll reconnect to that. So here I'm connected up there. So they've got me a machine out in the cloud for free. I'm just like hanging out. All my stuff's installed. And then I can just go here and start. I've already run a bunch of this stuff, but you just like, hey, let's. So anyway, like I said, I've run a bunch of this stuff, but when you get down to the when you get down to where it's like training the data, I guess I should start all over. But basically, it just kind of shows you what it does there. But when you're training, like it's like, oh man, this is slow, and that's where you're like, this would be nice to be running on the GPU. So this is just kind of, yeah, you can just run it all right here. You can get in there. You can like say, you know what? I don't want to do that. I want to change these numbers. I want to change this formula. I want to try to train it a different way, and you can do that right there. And then this just kind of shows you that. So this is the Python, but they've got some JavaScript stuff, Swift, iOS. You know, and Python stuff's mostly for building the models, and then you can deploy them on other things. I mean, like obviously everybody's phones have these like, hey, take a picture of that tree, and then it's like, that's a bur oak, and you're like, what? So that all that stuff's pretty awesome. And then all these cameras at your house, like, is it a person? Is it a person? Oh, it was a box, you know. But they've got face recognition, person recognition. So anyway, that's TensorFlow. Any questions that I might know the answer to? All right, that's it. Yes, I do.
I'm just going to say deny, see what happens. That's not what I wanted to do. Go back. There we go. All right, I'm going to talk about Bitrise. Bitrise is like a CI/CD thing for mobile apps. It's in the trial. I first heard about it because they advertise on Android podcast. So let's get into it. So they offer that they can help you sleep. I don't really know how that works out, but people use it. Some of those I've even heard of, like Mozilla, Virgin. They support your Android and iOS, but they also support Xamarin, Ionic, Cordova, React Native, Flutter. So I thought that was pretty impressive, especially when, I'll show you this in a bit, I just connected my project and then they told me that it was an Android app and they knew what to do with it. I didn't have to configure any of that. So you can set up workflows. That's their big thing. Set up different ones for master, develop your feature branches. So it'll, for example, test your code, install it, test it, export it, tie into your deployment tool, all that stuff. It will send Slack messages if you want, everything you want to do. They say they can do it all. You can run it locally to help you debug. I didn't mess with that. I didn't have time. but I'm sure it's awesome. So, get started in 60 seconds. That's like false advertising. That's very clickbaity. But maybe like 5 minutes might be realistic. So maybe if you were not doing your first one, you could get close to 60 seconds. So it does code signing, similar to what Robbie was talking about with Azure DevOps. You can deploy it anywhere. They have their own deployment things, but you can also integrate with other people's. I clicked into the security thing, and they had a lot of FAQs about your certificates and how they can handle all that, and if you have to comply with such and such regulations and how they meet all that stuff, and it was very snoozeworthy, unless you need that stuff, and then I'm sure it's riveting. So they talk about having a lot of integrations, and I didn't mess with any of them, but they probably have what you need. So, all right, and then they have a free plan. Maybe. I'm not sure. We'll go to that. So, now let's switch over. First thing when you're setting it up is you sign up for an account, and then you have to tie it to where you keep your repos. So I tried with my Bitbucket account, and it was pretty easy to set up. You get this scary, like, we need all the things to make this work, and YOLO, so you do it. So, and then it looks like this. And I didn't have a SSH key set up, so roadblock right away. But they just walked me through doing it, and it was pretty simple. So I appreciated that, because I usually just don't mess with that stuff. You go through and you select which repo you want to use. This is my gas buys Kotlin repo, which is a way of how I track where I buy gas and how much it costs and what the mileage was and everything. And you set up your key, and you select which branch you want to build, and I'm the only one that works on this, so I just have a master branch. It validates the project, and you can go click on that. You can't hear because it's just an image, but it'll tell you everything that they looked at and what they found and what they think this is. And then they say, hey, that's an Android project. So, and then you can say which module. It goes into some specific things, like if you're an Android developer, you know you have used modules, and it's probably an app module, that's the default, but it was. And then you have to pick which variant that you want to build. So I've picked my home debug variant. I have a few variants for if I was working on this app here at the office. I had an office debug because my homemade backend was different at different places, but that's neither here nor there. But they knew about it and knew that I needed to pick which one I wanted. So, and then they have, they build on Ubuntu machines for Android apps. And you can choose an icon, whoops. I never chose an icon for this app, but I'm sure if I had, they would have found it and offered it as a choice for their dashboard. And then they will set up a webhook. This part was also magical to me because I never messed with any of that stuff before either. And it was like, how would you like to just have us build this when you push to your branch? And I was like, yes, I would like that. And they told me to go here, do this, and really it was like push this button and push that button, and poof, it works. So, and then they kicked off the first test build. And let's see here. It started running, and that's what it looks like while it's doing that. And it was 45 seconds in there, and you can see it's on a standard machine. I think they use Google Compute for their machines and where they get those to. I don't know if that's configurable or not, but if you hovered over that on the web page, it told you that's what was going on. So, and then when it's done, you can look at the logs and the artifacts. So, and awesomely, this was great for my demo today. My first build failed, and I was like, oh, well, crap, because I hadn't worked on this for like 10 months. It was just a side project, and I didn't know what state it was in. It gets all the logs from the build, and then I went in and looked, and I had added KT lint to this project, and it was failing a lint thing, and so then I went in and fixed it, and then the next build worked. Hooray! So that's all for that part. Let's go back. I'm sorry. Here, this Update Studio Gradle version and fixed lint issues. Yes. Yep. Would you be more impressed if I told you that they told me that's what I did? All right, so you have your dashboard there, and then if you click on one of those, you get to this page, and it tells you how long the build took, which build it was. This was the first one, so there was no commit or anything. And then you get just the same logs that you would get if you were running it locally. These look a little bit different, or maybe they just have some highlighting. I didn't know what all of that was, but I was able to click into that and find what I needed to be able to fix my build. And then the other thing I wanted to show was the configuration that they generated for you is available, and you can go in and look at all this. And if your eyes start to go cross-eyed, it's kind of terse, but it's pretty understandable. It tells you what the steps are for the build and the deploy and what it was running. Here you can see it was running lint and the unit tests. So if you don't like looking at it that way, they also have the workflow editor with a nice GUI that I didn't have time to play with, but I would recommend checking it out. So, and then the same thing for the build that worked, and you can see that it's nice and green. This is, I was curious, like in Bitbucket, like what they did, and so I went looking, and I found the webhook is here, and so you can go in there and mess with it if you need to, but I didn't know what they did, and it worked, so I wasn't going to touch it. So you can click in and find your test results if you have unit tests, and it looks like this. Looks like very JUnity, so JUnit-ish, I should say. And then pricing. So Hobby, which is what I thought I signed up for because I told them I was a freelance independent developer when I signed up, is free. But if you notice, like I did, at the top here it says there's 11 days until my developer plan trial ends. So I'm not real sure about that and what that means and what's going to happen 11 days from now. Yeah, probably. So the other thing to note is I'm not real sure what it means about one concurrency. Maybe that's only one build can be going at a time. That's what I assume. Yeah. 200 builds per month? Oh, right. So that's what I want to talk about. Yeah. So if you go back to my builds, you can see that the first one that failed and quit early took 3 minutes and 10 seconds. And the second one that worked took 3 minutes and 50 seconds. There's a few more things it was able to get done. But this is a really simple app. Like, it's like 2 screens. It doesn't really do a whole lot. So I can imagine that when you are doing this, if you get into any kind of complexity, you're going to go over your 10 minutes per build real fast. So I think, yeah, I don't know what happens when that occurs. They'll probably just send you some ransomware and lock it on your computer. And then I found out today that guest speaker Matt Lorenz, his company uses this. So if you have any other questions, you can talk to Matt. So that's it.
Hello? Hi. Okay, I'm going to cover AWS Cloud Development Kit first. Nope, that doesn't work. That's going to give me troubles. Okay. So yeah, it's number 34 in the assess column on ThoughtWorks, and let me try to fix. Okay. Okay, so it is open source, just released, just generally available a couple months ago, and Apache 2 licensed, and it is makes it easy way to do infrastructure as code, so in a normal language, which is nice. And let me get to my repo. And so yeah, they have C#, Java, Python, TypeScript, also F#, and normal JavaScript as well. And just to show what it looks like, I wish, oh well. So yeah, to set up a whole VPC is just one line. To set up all scaling group is just here, and application load balancer, pretty small, and yeah, that's it. Let me start this install process for this while I talk about constructs. So what makes all this possible is they have an idea called constructs. And there are low-level ones and high-level ones. Some of the high-level ones so low-level ones will look like setting up an ECS cluster with, you have to specify the cluster and the service and the task definitions and the containers, or you could just use like this load balanced EC2 service construct and specify a couple properties there, and it will create the whole thing. So that part is nice. And they have a command line utility. I've just used init, deploy, and destroy so far. And so it's really just creating cloud formation templates in the background. Let me show you those while it creates them. So yeah, it's just doing all of this in the background. So it seems good if you are doing something pretty boilerplate where there is a nice construct for it available already. And it's going to take a long time. So I'll move on to my second one. Commit is in. Let me pull it. notes. I don't have a link. And this one's in the adopt category here. Pretty high up on the list. Looks like it was started about 5 years ago, and it, I guess you normally set it up as a Git hook to run to make it easy to standardize on your commit messages. So I can show what that looks like. That's still creating. And let me show, let's see, so running commit-send init with the adapter that you want to use, we'll set it up in your package.json, and you can either set up the Git hook just manually, or you could use Husky, and this demo app actually has Husky enabled but not doing anything yet. And yeah, the one that they demo with is with conventional changelog, and I also tried out this Jira Smart Commit one. It'll take a little bit. Oh, there we go. And to add it to Husky is somewhere. Oops. Then yeah, whenever you commit, so yeah, let's commit all this. Where you normally go, just add commit is in. It will then prompt you to mark it as a feature, chore, fix, and maybe this is common, but this is I think, first time I've ran into it, and I do notice now that some repos I've been working in use this, and I just never knew. And let me also show the Jira one. It's probably more handy. Actually, I had that. Oh yeah, and to jump back to CDK, it finished creating, and you'll see we have an EC2 instance up, as well as a load balancer, all from that boilerplate code, and that can be customized. But yeah, let's try with this Jira Smart Commit one. Cool. Oh, it sees the previous adapter. tough luck. There's a, well, you'd have to install it with npm first globally, I guess, to get the commits in binary. But then you could just set it up manually as a hook. I'll show you what the GitHook looks like. I thought it was some different. Oh, Husky's doing something. But yeah, you just put this in as a Git hook. Or sorry, not that. You put in just git dash cz or commit in binary itself. So it would, it's not as nice, I guess. But yeah, here's a Jira Smart commit one, commit message test, and Jira issues tag it to, and you can do closed, and if you use tracking and another comment, and that ends up looking like a message like up here. No, it just pretty dumbly just puts it in. And yep, that's all I have to show.